Hello. Hello, this is the My Artifact episode number 4156. Today's date is July 17, 2026. It's been almost like a morning at 8:35 a.m. Alright. Let's just jump into the question. Let's go. Alright, so question is what makes Adam different from ChatGPT and Gemini? Okay, what exactly is this question and why am I asking this question to myself? I wanted to build a AI that could predict the future. Before I wanted to build such a AI that could predict the future, I wanted to aware of all the possible consequences. So that's why I am asking this question. By the way, this question actually generated by ChatGPT. I kind of like a simply prompt that key I wanted to build such a AI that could predict the future. Suggest me kind of like a hundreds of possible consequences in question format. ChatGPT kind of like a suggest me hundreds of question. This is one of those question. By the way, question actually in the mobile phone, but while recording I cannot do anything at all. So that's why I wrote the question in here. This is the question. Alright, so let's talk about something that key difference between Adam and difference between Adam and kind of like a conventional AI and things like that and that. So the conventional AI model are actually run on GPU. Okay. First of all, why they are kind of like a running on GPU? Before I wanted to kind of like tell you everything, let's just comparison between the kind of like a conventional AI and the Adam. Okay, Adam is a little bit of futuristic, but let's talk about the conventional AI like a ChatGPT, Gemini, Claude, Anthropic, all the kind of like a something like the conventional AI that are exist. They are kind of like using a GPU. Okay, why not they are using a CPU? Like a CPU is a kind of like a much more faster, right? Well, imagine as a kind of like that ki, um, imagine is a kind of like that ki, um, a CPU is a Leonardo da Vinci who can paint a painting a very like a thoughtfully. You the Leonardo kind of like put a lot of thought process while creating that painting. So imagine as a CPU as a Leonardo da Vinci who could kind of like somebody put a lot of thoughts into the painting. He could paint a painting very beautiful, but it takes so much amount of time. Okay, now instead of like let's talk about the GPU. The GPU is a kind of like a somewhat something is a kind of like it's not a painter, but it's a kind of like a somebody a people who are kind of like a somebody willing to paint. Okay, yeah, they just know how to do the brush. That's it. Okay, but those GPU are very kind of like if you give them instruction, they will follow the exact instruction. Okay, so a kind of like a something X amount of time, a CPU can paint a painting, a one painting, but the same time the GPU can kind of like a paint hundreds of painting in a X amount of time. Why? Because it has a so many kind of like a cores, like a so many kind of like a Leonardo, but they are not Leonardo, a kind of like a worker. Like CPU is a considered as a kind of like a strong Leonardo who could paint a very beautiful painting, but GPU considered as a kind of like a typical normal people who are know how to use brush and that's it. But those people are thousands in number. Okay, so that is called kind of like a GPU and CPU. A GPU is a kind of like a something trained to follow the instruction, and from that instruction, it could kind of like a perform, deliver the task, and things and that and that. The the GPU is a really good at parallel processing. What's the parallel processing? This is one process. This is another process. Both the process actually happen at the same time. That is called parallel processing. The CPU is not really good at parallel processing. CPU because it has a kind of like a very less amount of core, like a basically 5 core, 6 core, 7 core. Okay, yeah. So that means he could kind of like a handle maybe kind of like a 6 to 7 tasks at the same time. But instead of GPU, it could handle kind of like a thousands of tasks at the same time. So that is a kind of like a difference between the CPU and GPU. um, yeah, this is what it is. Like I'm not kind of like a give you, like I'm not kind of like a really credible particular person who kind of like a give you exact difference between that, but there is a like a somewhat something, a kind of like a normal difference. Okay. Now, why does we use GPU to run our AI algorithms or AI things? Well, AI is a kind of like a large language model processing. Large language model processing means what? It means that na ki the AI is a large language model. It has a kind of like a so much amount of data are actually feed inside their database. So much amount of data, like whatever the kind of like a data that humans actually created till now, all the data, books, information, report, everything actually kind of like a store inside the database. And the large language model like a ChatGPT or Gemini access that database, and from that database it could kind of like a generate the possible outcome of what would be the next text. If you wanted to understand the context, let me kind of like a simplified. If I'm gonna say thank you, okay, so what would be the next reply would be? We are human, we understand this thing, like if someone gonna say thank you, we say welcome and that, right? Okay, but large language model like a chat gpt or Gemini does not really understand what do I supposed to say after the thank you. So what does it do? What does chat gpt or Gemini does is that it kind of like a went through thousands of kind of like a parameter regarding about that whenever the last time someone used thank you, what do I supposed to be say? Okay, and it kind of like access thousands of kind of like a something like the data where it kind of like a store, and it kind of like a says okay, after the thank you we should supposed to be said welcome. Then probably from that thing it kind of like a generate that after the thank you it kind of like a reply as a welcome. Okay. The large language model are generative model. They are kind of like a generate the kind of like a context regarding about what is actually the data it feed. Okay, so that is called kind of like a some generative model. That's why we called as a chat gpt or Gemini are generative model. They are kind of like a generating the kind of like a content or context regarding about the whatever the data that it has. That is called kind of like a generative model. Okay. Now why we use kind of like a GPU is because of that because of the AI or large language model kind of like a goes through millions of kind of like a something data points to kind of like a collect the data regarding about the collect the kind of like information from the massive data. So there is a lot of parallel process actually happen. Okay, and from that parallel processing, CPU cannot able to be handled, because CPU can handle maybe kind of like a 6 to 7 tasks or maybe 100 tasks at at the same time. But GPU at the same time could kind of like handle thousands or maybe kind of like a millions of kind of like a process at the same time. So not millions, probably, I'm not really sure about that, but kind of like a GPU is kind of like a somebody very much efficient for parallel processing, because each processor kind of like a calculate millions of calculations and things and that and that and that. So that's why we use GPU to kind of like use our generative model or large language model. We simply cannot use CPU. Okay. Now this is not just a one thing. Another thing is that the CUDA. CUDA is a kind of like a kind of like a language where kind of like a people could talk, like not just people, like a software could talk to the chip. Like basically is this thing, we have binary code. Okay, yeah, that binary code is actually kind of like a talk with the kind of like a somebody CPUs and GPUs and things and that and that. But CUDA is a kind of like a somewhat something that key excellent to kind of like a talk with the GPU. The CUDA is a, it's imagine as a kind of like a somebody language, a kind of like a somebody translator, and that translator is a kind of like a we could talk and we could kind of like a get the output as fast as it can. So that's why kind of like most of the kind of like something the large language model are kind of like using GPU. Okay, specifically NVIDIA's GPU. Google are actually using a TPU, kind of like a tensor processing unit, which is also a kind of like a somebody how how which is all which is also a kind of like a somebody kind of like a something CUDA based probably thing. I'm not really sure about that, but this is what somewhat something. So most of the AI are kind of like a run parallel processing, and most of the kind of like somebody AI is actually run on GPU. Okay, now let's talk about the kind of like a Adam. Okay, so Adam is a kind of like a AI that could predict the future. Okay, now basically is this thing. If I'm gonna say predict the future means what? It kind of like a do the forecasting. It kind of like a do the kind of like a somebody the runs the simulation, because in the large language model the it generative information, like basically it kind of like a collect the information from the data set and it kind of like a show it in front of you. That is called generative database, ChatGPT, Gemini. But simulation is a kind of like a very different thing. It's not generate, it's a kind of like a create. It's a kind of like a somebody this thing analyze with has a kind of like a back end data and things and that. Like a let's just say weather forecast. So weather forecast is kind of like a run by the simulation program. Like basically what exactly happened, the like basically on the top we have kind of like a lot of satellites. Those are satellites are taking the thousands of photo at this like a thousands of photo of the sky every single second. And from that thing it could kind of like a predict. Example, let's just say this is the cloud, this is the like let's just say this is the cloud. This cloud is kind of like a going from this direction to this direction. So at 1 second it is over here, second this would over here, over here, over here, over here, over here. Okay, so what would be kind of like after 1 minute where this cloud would be? Obviously it would be over here because we knew the path. So basically we kind of like a predict that key the cloud would be over there. Okay, so this is called kind of like a prediction. Like we could understand the kind of like so many things and that, but it's not that much that easy as it is. Okay, there is a lot of kind of like some butterfly effect is actually happening. Butterfly effect means like chaos theory, means like that one wind or one kind of like a disturbance kind of like a disrupt the entire prediction model and things and that. So that's why the simulation is actually happen every single second. It's not really stop. Like if I'm gonna say generate the image for me, ChatGPT kind of like generate the image and stop. But the simulation model does not stop. It always continue. It always continue to kind of like make sure the prediction pattern is always be kind of like a simply understandable. It always be kind of like a simulate, always be new before where it should supposed to be. So that's why the it's always be running. The simulation model is always be running, always tracking the cloud where it should supposed to be in that and that and that. And from that data, from that backend data, like basically is this thing, the generative model capture the information from massive database, but the simulation model is actually create the database, and from that database it create the kind of like a some structure. It kind of like a finding the pattern, and from that pattern it kind of like a predict the possible future. Okay, so that is what kind of like the prediction model. Okay, so this is what kind of like a things. Okay, now the problem is that the simulation model is a kind of like a is not a parallel processing. It's a kind of like a somebody the like as I mentioned, like basically the GPU is parallel processing, which has a kind of like a thousands of cores are kind of like a run at the same time to kind of like a generate everything and things like that. But in simulation context, no. In the simulation context, a kind of like a very smart kind of like a some processor really required, and that processor would be a kind of like a CPU, because CPU is actually much more faster, sorry, much more kind of like a smarter. So basically is this thing, like basically the prediction model is actually based on the accurate reading na. Like basically that's why we are kind of like a getting the weather updates approximate. Like basically it's not really exactly but approximate, but which is kind of like a run on real numbers and things and that. If the weather patterns are kind of like a forecast they are thinking on GPU, the pattern would be kind of like the simulation cannot able to process very much clearly. Why? Because of that key it's not really right. The like basically we need a kind of like a very smarter processor, and that's why kind of like we use a kind of like a supercomputer to kind of like a forecast the weather or kind of like a stock market or things and that to kind of like a find the predictable pattern regarding about that where we should supposed to be lead. Now prediction pattern means like that it doesn't means it could kind of like a predict almost like 100 year after and things and that. No, it could kind of like a predict maybe kind of like a somebody the maybe 5 minute, 1 day or 1 week or 1 month. Okay, yeah, and as much as you kind of like move further, the prediction model get kind of like get weaker and things and that. It could kind of like predict the kind of like somebody whatever it is close to the kind of like incident. Okay, like basically today's date is what's today's date? Today's date is 17th of July 2016 2026 17th of July 2026. So prediction model kind of like a simulate the like kind of like a predict that 18th of July what will gonna happen, 19th of July what will gonna happen, but not kind of like a year after and things like that. if yeah, like a prediction model can predict the kind of like a year after what will gonna happen to, but the it does not have that much accuracy, because the chaos theory or kind of like a butterfly effect is actually impact on lot, and because of impact a lot, the probability ratio is kind of like a get little less. So because of that, it does not kind of like a things and that and that. So do you understand? So it's kind of like a somebody, we need a kind of like a processor to kind of like a much more smarter and much more kind of like accurate. Now we are using today, we are using a supercomputer to kind of like a run on those kind of like a forecasting, weather forecast, kind of like whatever it is, okay, like a tracking the meteor tracking, like a basically existing on the on the space. There is kind of like a billions of kind of like a meteor and kind of like a planets and stars and things and that we track them, that ki where it should supposed to be, which kind of like a meteor might gonna hit on the planet or some sort of planet, or kind of like a things and that we kind of like simply do the calculation, figure it out their path, where it should supposed to be and things and that. As also we also calculate the where the planet position, things and that is called kind of like a forecast or kind of like a prediction model, which is run on kind of like a something the uh, supercomputer. But right now we have a kind of like a simply we invented kind of like a computer which is kind of like a much more faster in the much more faster than kind of like a normal computer and classical computer. And what is that? That is called quantum computer. A quantum computer is not a replacement of GPU. No, like a supercomputer. Imagine as a CPU, and GPU is a GPU. Okay, yeah, those are completely two different things. Okay, now quantum computer can replace this a kind of like a supercomputer, but cannot replace the GPU. Why? Because GPU is a kind of like a really good at generative text and things. It could access the kind of like a millions of database and token number at the same time. But the quantum computer is not. Quantum computer is a kind of like a predictive analysis, creating the kind of like a database to understand the pattern with kind of like a precise calculation and things and that. And for that particular process, the quantum computer is actually utilizing. And quantum computer are really good for kind of like a simulating the process. Like it has a kind of like basically existing in the simulation process. There is a kind of like a millions of parameter regarding about the a particular incident. Example, if I went to the school, there are kind of like a millions of way to go to the school. Okay, like even if you have kind of like a three paths, but like regarding about how should you supposed to choose this path, what might gonna happen, things and that and that and that and that and that. So basically for the prediction point of perspective, there is a kind of like a millions of kind of like a somebody the possible outcome would be, and basically the simulation is a kind of like understand that millions of possible outcome, and from that millions of possible outcome, which kind of like a show it to you what is actually the probability that could kind of like a showing you correct path to kind of like go to the school and things and that. By the way, going to the school is a kind of like a very basic kind of like an example that I mentioned, but in the simulation process, it kind of like happened through so many stages, like a millions of consequences and things and that. And for that millions of consequences with a precise calculation can able to be do by the kind of like a quantum computer. Okay, but quantum computer have a kind of like a, some sort of amount of limit too. What is that limit? Like a quantum computer are like why does kind of a quantum computer are really great regarding about the classical computer. The classical computer are kind of like a a classical computer means like CPU. The classical computer can able to be handle maybe kind of like a something, let's just say thousands of kind of like a calculation at the same time, precise calculation. Quantum computer in other hand kind of like a calculate maybe kind of like a millions or billions of calculation at the same time. Okay, but the problem is that in the quantum computer there is a kind of like a somebody like a it's run on kind of like a qubits. Okay, like a classical computer run on kind of like a bits, but quantum computer run on qubits, and qubits are kind of like a somebody have a like a it kind of like a, it change the kind of like a position. Okay, a bit might be kind of like a 0 or 1 at the same time, or maybe like 0 or 1 maybe kind of like in one time or things like that. But quantum computer kind of like a shows 0 at 1 at the same time because of the like a entanglement and kind of like a things and that. So basically is this thing that ki like expand the classical computer is kind of like a much more easier. You can attach a multiple CPUs and things to kind of like increase the power and things and that. But the quantum computer if you wanted to do this thing, it's not really possible, at least not possible, because of that key. It kind of like a something that key, interference and coherence, I'm not really sure about this particular terminology, but because of this thing it kind of like impact on their processing. Okay, so basically for that thing, like basically is this thing that quantum computer kind of like a process, it really required to kind of like a solve the kind of like a coherence and interference and things and that, like basically imagine as a kind of like a somebody, quantum computer is a kind of like a so smart, but it could kind of like a somebody showing the smartness in AC room. Okay, yeah, if he cannot able to be show the smartness in kind of like a somebody the day, in everywhere situation, no, like a quantum computer is a kind of like a somebody so smart kid that could kind of like show his skill in a kind of like a AC classroom. That's it, like he can perform really well in AC classroom, he will not gonna perform anywhere at all. So basically he has a kind of like a somewhat something that thing, and we have to be figure it out that like every situation is not kind of like a provide the AC classroom every single time where client the kind of like a quantum computer kind of like a perform really well. So that is kind of like a things we are kind of like a try to figure it out that key, how do we supposed to be kind of like a giving that interference and coherence pattern kind of like a, as much as less is possible. Because of that key, a quantum computer really required a kind of like a absolute zero temperature to kind of like a process, to process this thing. Absolute zero temperature means like that minus 235 degrees Celsius, which is very like a very cold, and kind of like a somebody that key achieving this kind of, oh, achieving this kind of like somebody temperature is a like a very difficult. Okay, yeah, like it is not really difficult, but it's not really kind of like a that we could kind of like a create a room with minus 275 degrees Celsius, definitely not. So basically for that particular quantum computer chipset, basically if you wanted to utilize that, right now it's kind of like in the beginning stage, by the way. So in regarding about the quantum computer, like probably it's like it's on the beginning stage. I'm not really sure what will gonna happen, like regarding about all the possible things. But one thing for sure is that Adam is a kind of like a run simulation program. It could kind of like predict the possible consequences. So from that possible consequences, Adam really required a kind of like a quantum computer to kind of like a run their simulation program. But it's not really that much that easy. Okay, yeah, because I need to use both like a GPU and quantum computer at the same time, because GPU is a kind of like a like basically I have a data. Okay, because like basically Adam is actually backed by Artifact, and Artifact has a kind of like a massive data library regarding about all those people thoughts and things and that. So from that thing it could kind of like generate the possible generate the kind of like data, the kind of like a raw data, and from that raw data it could kind of like simulate the further simulation by quantum computer. So I need both as a GPU and kind of like a quantum computer at the same time to kind of like run the simulation. Okay, but still it's on the beginning phase and things and that. So the question is that what makes kind of like a difference between the ChatGPT and kind of like a Adam? Well, Adam is not a generative kind of like a AI. It's kind of like a predictive AI. It's a kind of like a forecasting, kind of like a future possible consequences and things and that. It's not kind of like you put the prompt, get the answer. No, it's not. It kind of like a run continuously non-stop to kind of like a making sure the simulation is always been kind of like exactly as it is and things and that. The process really required to kind of like somebody execute the prompt in GPU or kind of like a in a kind of like somebody ChatGPT things, it's kind of like a far less time. But kind of like somebody the Adam kind of like takes so much amount of time to kind of like somebody execute the one single prompt. Sometime it might gonna take kind of like hours or maybe days or things and that, because constantly kind of like a running kind of like a millions of possible outcomes and things and that. And that is a kind of like a things Adam kind of like a learn from that possible outcome. Adam can kind of like a learn from kind of like a pattern, and from that pattern it could kind of like a try to predict the possible future. Okay, with confidence level, with kind of like a probability that how much confidence that has and things and that. But still there is a lot to need to kind of like a figure it out and stuff like that, but still it is a lot of stuff. So what makes kind of like a difference between Adam and ChatGPT? Well, as I mentioned, ChatGPT and kind of like a somebody Gemini is kind of like a run on classical computer, like a not classical GPU, but like why not kind of like a ChatGPT and Gemini are not use quantum computer? Well, quantum computer is not actually made for parallel processing. Like for the parallel processing, quantum computer is just suck. like literally suck. It's kind of like a suck than kind of like a some normal CPUs. Okay, like a normal CPUs kind of like a perform really well in kind of like a sometimes kind of like a perform really well. Like let me tell you one thing. The If you wanted to generate the kind of like a context, the GPU is kind of like a much more better things. Okay, yeah, because it has a kind of like a thousands of cores at the same time, kind of like a run. But the precise calculation, the CPUs and quantum computer are actually much more better. Okay, so for the simulation process, precise calculation is actually much more essential, and that's why I use the quantum computer for the simulations and things and that. The generative piece of content is also precise, but it kind of like a collect the data from whatever the data that it has and kind of like a simply generate the kind of like a thing. So that's what it is. So it's a kind of like a difference. All right, so this is a kind of like a somewhat something kind of like a just normal difference. Okay, there are so many things. Okay, right now I am kind of like I don't know what will gonna happen, because like the stuff that I said is a kind of like a much more easier and much more kind of like a some stuff that it says, because but when I will try to implement that thing or execute that thing, it takes so much amount of effort, thought process, and lot of things. I'm not really sure what will gonna happen, but I'll try to make sure that it might gonna happen. All right, so this is it. I have to end here. Thank you.